So now we will write a program which reads 10 real numbers. Then the program must show the maximum and the minimum of these numbers. Okay, so in order to solve this problem, we will do the following. First of all, we will read the first number from the user, and then we will suppose that this number is our minimum and this number is our maximum. Okay, then for each number that the user enters, we will compare this number with the minimum and the maximum. If this number is less than the minimum, then this new number will become our minimum. And if this number is greater than our maximum, then this number will be our new maximum. And at the end, we will have the maximum and the minimum. Okay, so first of all, I'm telling the user to enter the numbers, and I'm reading the first number from the user. Okay, so now we will suppose that this number is our minimum and our maximum. So int minimum equal n and maximum equal n. So this is how we declare two variables of the same type on the same line, and I'm initializing both of them to be equal to n. Okay, now we should take the rest of the numbers from the user. So for int I equal 1, I less than or equal to 9, and I plus plus. So this loop will run 9 times. We took the first number over here and we still have 9 numbers left. So in this loop, we have to read the number from the user. So I'm going to read an integer and store it also inside n. And now this number should be compared to our minimum and our maximum. So we will do this. Minimum will be equal to, and we will use a ternary operator. If the new number n is less than our minimum, then our new minimum should be this n. So if this is true, n will be our new minimum, and if this is not true, our minimum will stay as it is. Similarly for the maximum, if n is greater than our maximum, the new maximum will be n, and if it is not, the maximum will stay as it is. Perfect. Outside of the loop, we will printf minimum equals %d and maximum equals %d, and we will print our minimum and maximum. So this is our solution. Let's try it, build and run this. So enter your numbers. Let's say the first number we enter is 5. Now 5 is stored inside our minimum and our maximum. Now I will enter 3. So what happens right now? Is 3 less than 5? Yes, this is true. So minimum will be equal to 3. Perfect. Is 3 greater than 5? This is false. So maximum will still be equal to 5. Now let's for example enter 9. Is 9 less than 3? This is false. So minimum will still be equal to 3. Is 9 greater than 5? This is true. So maximum will be equal to 9. As you can see, we are getting the minimum and the maximum perfectly. Let's enter the rest of the numbers. As you can see, the minimum is -1 and the maximum is 9. And this is true. The greatest number is 9 and the smallest one is -1. So the idea here is to keep track of the first input and then compare it with the rest of the inputs. So now we will write a program which reads a sequence of positive real numbers, which are integers. Then the program stops when the user fills a negative number. Okay, and then we must show the maximum and the minimum of these numbers. So we already solved a question where we read a sequence of positive real numbers and stop whenever we enter a negative value. And we also solved a question where we get the maximum and the minimum. So this question is a combination of the two questions, and it should be easy enough. So let's solve it. So first of all, I'm taking the first number from the user and storing it inside n. And if the first number the user enters is negative, then I'm ending the program over here. So there is nothing to do. And now if the number is not negative, then we will get the minimum and the maximum. So as before, I'm supposing that the minimum is n and the maximum is n. And as you know, we don't know how many numbers we are going to read. So we will use an infinite loop. So while 1, for example. And in this loop, we will read the numbers from the user. So scanf, and we're going to read an integer, and we will store it inside n, as you can see. Now, if the user enters a negative number, we have to stop. So if n is negative, then we will break out of the loop. Okay? And if n is not negative, now we will compare it with the minimum and the maximum. So minimum will be equal to, if n is less than our minimum, we will store n inside minimum, and if it is not, minimum will stay as it is, and maximum will be equal to, if n is greater than our maximum will be equal to n, and if it is not, the maximum will stay as it is. Perfect. And outside of the loop, as you can see, I'm printing the minimum and the maximum. So this should solve our problem. So let's build and run this program. Let's enter a negative number from the start, so -5, and as you can see, we did nothing and the process returned 0. This over here. Perfect. Now let's run the program again. Let's enter 5, for example. Now let me enter a negative number, let's say -1, and as you can see, the minimum is 5 and the maximum is also 5. Perfect. Let's run the program. Let's enter 5, 2, 1, 0, 99, and now let's enter a negative number, let's say -1. So the minimum is 0 and the maximum is 99, and this is true. Perfect. I want to say one thing. If you tried to solve this question, you might have put this if statement after the minimum and the maximum over here. This will lead to a wrong answer. Why is that? Let's suppose that the user enters -1, and all the previous numbers are of course positive numbers. So the number that the user entered is of course less than our minimum, and it will replace the value inside our minimum, and this is why we will get a wrong answer. So let's build and run this program. Let's say we enter 5, 0, and now we enter -1. We expect to see 0 and 5, but instead we see -1 and 5. So the position of this if statement is important. We have to put it over here. So whenever we enter a negative number, we get out of the loop and our minimum is not modified. So now we will write a program to find out if a 4-digit number is a lucky number. What's a lucky number? Let's imagine that we have ABCD, a 4-digit number. ABCD is a lucky number if A plus B equals C plus D. So the idea behind this exercise is to be able to work with the digits of this number. We have to get the digits AB and add them together, and the digits C and D and add them together, and then we will see if A plus B is equal to C plus D. So in order to solve this question, we will use the division and the modulo operator. Let's imagine that we have this number 1, 2, 3, 4. Okay? To get the last digit, which is 4, we do the following operation. We do 1, 2, 3, 4 modulo 10. This is equal to 4. Okay? Now, in order to get the 3, all we have to do is to divide 1, 2, 3, 4 by 10. So this will be equal to 1, 2, 3 because this is an integer division. Now, if we take 1, 2, 3 modulo 10, we will get the 3. Next, let's divide 1, 2, 3 by 10. This will give us 12. 12 modulo 10 will give us 2. And now we still have to get this one over here. So 12 divided by 10 is equal to 1. And 1 modulo 10 is equal to 1. So this is the idea. The modulo of an integer gives you the digit on the right, okay? And in order to get the rest of the digits, we will use the division operator in order to get rid of the first digit. Perfect. So let's see our solution for the lucky number. First of all, I'm printing an integer and I'm printing a condition over here. So this integer will be 0 if the condition is false and will be 1 if the condition is true. Now let's have a look what I'm doing over here. I'm adding n modulo 10 with n divided by 10 modulo 10. So n modulo 10, let's imagine it is d. n divided by 10 modulo 10, we will get rid of d and then we will take c. So this over here is d plus c. Perfect. Now we are comparing d plus c with this over here. So this is n divided by 100 modulo 10. So we will get rid of d and c and then we will take b. So this over here is b. And then we are adding this with n divided by 1000 modulo 10. So we will get rid of DCB and then we will get A. So this over here is A. So we are comparing D plus C with B plus A. If they are equal, we will print 1, and if they are not equal, we will print 0. It doesn't matter what we print. I want you to understand the logic behind this modulo and division operators. So let's run the program. Let's try 1, 2, 3, 4. Obviously, 1 plus 2 is not equal to 3 plus 4. So we should see 0. And as you can see, we have 0. Let's see another example. 3 plus 5 and 4, 4. So obviously 3 plus 5 is equal to 8, which is equal to 4 plus 4. So we should see 1. Let's press enter and we have 1. Perfect. Let's see another example. 1, 2, 2, 1. So we also should get 1 because 1 plus 2 is equal to 1 plus 2. So press enter and we have 1. So this is our solution for the lucky number. As I said, I don't care about the output, I just care about the logic. If you want to make the output better, let's take this condition and store it inside a variable. As we saw before, this variable can be an integer and can be a boolean. Let's make it an integer in this case, so let's call it isLucky. And let's set it to be equal to this condition. And now in this printf, we are going to print a ternary operator. So if isLucky, I'm going to print lucky number. Okay, and if it is not, I will print not lucky number. Let's run the program. Let's enter 1533. So 1 plus 5 is equal to 3 plus 3. So we should see lucky number. Press enter and we see lucky number. Let's have a look at another example. 1, 2, 3, 4, not lucky number. Perfect.